My name is Carlos Roldan, and today I'll be introducing Avicenna, my Bitcoin Games Hackathon project. So let's first jump into the problem. Ensuring a healthy life and promoting well-being at all ages is important to build prospective societies. However, despite great strides in improving people's health and well-being in the recent years, inequalities still persist. More than 6 million children die before their fifth birthday each year, and only half of all of the women in developing regions have access to the healthcare they need. According to the United Nations, and 87% of these healthcare facilities where are in third world common countries are based on standard paper records. Standard paper records can be compromised in two ways: by being misplaced or being stolen in the unlikely event of a break-in or a natural disaster, such as a civil war. So, Avicenna aims to improve this as an alternative healthcare system designed to survive in the most radical environments with low technological infrastructure or access. The way it works is simple. So we first digitize every healthcare camp by providing notes to be recorded in an electronic healthcare record system. Those data of each patient is then added into the IPFS node of the Avicenna's platform, forming a network of IPFS nodes that they can share an immutable data of each patient. Once this data is inside, we create an authenticity certification using Bitcoin technology, such as open timestamps for certification of a proof of a stamp, or the Blockstream satellite, where we introduce the hash data of the immutable document once has been inside the IPFS node, and then we retrieve it using the auth token and the UUID. Third, and more important, the user is always the owner of the encrypted data. This data is accessible through a QR code, as it serves as an IPFS gateway to access the data, creating an interesting behavior here because only doctors or high qualified healthcare practitioners are the only ones to issue passports, medical passports for patients, but only patients are the owners of this data and they're able to unencrypt the data. This is inspired of the public private key encryption. Let's jump ahead into the features. So we can see that we have in Avicenna provides e-medical records. So in an electronic manner, it has all of the systems and it has been designed by SCORE to be accessible from the phone. It's non-custodial because Avicenna provides certification and it provides donation pages for clinics and healthcare facilities where the same clinics and healthcares can add their macaroon invoice, and so Avicenna only issues new payment requests. Alternatively, when deploying Avicenna in your healthcare facility, you can add your own node details. So more into detail, gRPC endpoint, your macaroon, and your TLS certificate. In case you don't want to go non-custodial due to inbound issues or capacities or channel administration of your Lightning node, you can also go and run a custodial way, which is implemented using OpenNode. It also uses Bitcoin certification, as I just mentioned before. It can create the e-medical records, also have a medical prescription into the document, and it also has a identity section within the document. You can find all of this information in specific detail in the project's wiki in our GitHub. It provides an offline access if there is a IPFS private offline network. And once the data is in IPFS, it's immutable and it has a unique hash. If the data is updated, it updates the hash, creating a different document. Let's try it out a demo. Let's say I use run this. I just run this experiment, and I just want to deploy this platform into my healthcare facility, and I'm gonna start as an admin. So first, I'm gonna. So for this case, for this demonstration, as an open demonstration, I'm enabling the experiences of the three permissions of the platform, so clinic staff, doctor, and admin, because the way this has been designed is in a closed way, where the healthcare facility, before being deployed, the administrator who deploys the platform itself, once is applied and one has login for first time, becomes admin, and then it can add other users. So only the administrator can add other clinic staff users, can create clinics, and can create doctors users. So only previously registered members of the organization can be logged in. For the sake of this demonstration, I'm making this public so you guys can test this application as any permission. In this case, for this demonstration, I'm acting as an administrator. So once I log in, I'm going to sign a message using my Bitcoin private keys, and when I confirm it, I log in and I verify that the same message is the message that my wallet was signing. And from the admin dashboard, it's very simple. I can visualize the users. I can see if they're the doctor, clinic manager, their staff. So I can add new users easily. I can add new clinics by typing a name. I can do some clinic management, so I can move some users into our clinic. I can update the clinic name. I can add users into a particular clinic or remove users from a clinic. And here there are some information that basically specifies that for this demonstration, since every user can, quickly log in as an administrator, I'm not enabling in this demo the live settings, so everyone could easily change the node in a non-custodial manner and point this to their node, so they can receive all of the transactions to their node. So this can be easily, for changing the line settings can be easily done in the environment files, and there's a really well explanation in the wiki, as you can see. So this is what you can do as an admin. I'm gonna log out and I'm gonna log in as a doctor right now. So okay, I'm gonna log in. I'm gonna sign my message on the Bitcoin network, and I'm just logging right now, and I'm going to create a passport. So I need to first update my profile. I'm gonna say I'm Carlos, and this is my email. My street is this street. I am a doctor right now, and this is my phone right now. So I'm gonna save my data, and I'm gonna create a passport. So let's say that now I am with a patient, and I'm gonna put, let's say this is the picture of the patient, and I'm gonna add inputs, specific inputs of and data fields from the patient, such as the blood type. I can type. I can say the name can be Satoshi's Games, and the date of birth was last Saturday. It's a male, and then we just cover the identity section of the passport. Now we can cover details about the report. So let's say that I may have a resolved condition of epilepsy that happened to me on the 10th of May, and it was an epilepsy, and I can add more data about it. So I can add this a condition and add as much conditions as I can, or as the patient has. I am allergic to dust and it's high risk because blah blah blah, and I have Pampers patching on the 2017 on May 16th. Then let's say I don't have any social history issues, so I am all independent, so nothing to stand and nothing to talk about my functions and activities or my social behavior either. So let's continue. So now we cover also the electronic medical record, and now we have the medication. Because this is intended to be in a network of communities with low infrastructure, so they can deploy this application into their IPFS network and they can work in the same way as the current system, but the only difference is like only having mobile devices, and let's say that a chemistry or a pharmacy or a clinic, they're in different ways, but they're connected through the same IPFS network and they share the same data. You can share and you can verify the same content of a specific user once it has been issued, the passport. Let's say that I'm gonna now prescribe you insulin 10 grams on Thursday and Saturday, and I can type here the posology. So now let's save and continue. And now we can choose the certification method between open timestamps for stamping proof or blockchain satellite, also for certification. So let's choose this one. I think it's a cool one. I like it. And now I'm going to confirm that this data has been approved by me, which I am a doctor of a specific clinic. I can confirm that the patient has written here the password to encrypt his data. Let's say that now I'm going to turn my phone or my laptop to the patient and I'm just going to type a password, 123456 in this case, and that I agree to share my email and phone number to the passport in case of an emergency happen. I can be contacted easily. I'm going to issue the passport right now, and I'm basically going to sign the same as here, as what it used to be here before when I was clicking the checkboxes, but in the Bitcoin network. So I'm going to confirm this message and I'm going to sign it right away. And right now, my passport is being encrypted and uploaded to IPFS. Once this has happened, it's going to upload this IPFS data to the blockchain satellite. So I'm going to pay for this. I'm going to scan this QR and I'm going to pay it just right away. Once it's been paid, is uploading again the certification and the data of the passport to IPFS to generate a secure gateway to access this data. So this is the gateway. As you can see, this is an IPFS gateway where we can see once is updated. It probably takes using an Infura API around 10 minutes, 15 minutes. But if you're using your local IPFS node, as is the most recommended option, as the wiki for the deployment describes, is instantly accessed as is your local device. This is a link provided by the Avicenna's platform website that, for the sake of the demonstration, it will provide the passport, and after 1 minute approximately, it self-destructs automatically. This just basically downloads the QR code so you can print it to the patient. So let's watch this quickly before it disappears. Okay, I'm accessing now this data. And let's say that now the user comes and puts their password, or they can provide the password to the clinic, and the clinic can become a custodial entity that stores the password to encrypt every single passport key that's up to the clinic or up to the environment. This is where the most important and beauty comes and takes place. So here, I'm also gonna come here and I'm gonna switch my role. I'm not gonna be anymore a doctor. I'm gonna be a clinic staff or a chemist in a pharmacy, that someone is coming to a passport, and I'm gonna validate if this passport has the authority and is an authentic and a proof. It's bulletproof, so you can not fake this document. So someone comes with this data, and I'm gonna verify that this data exists and it's not fake. So I'm gonna be another doctor of another platform, let's say, and I'm gonna come to validate passport. So here you have a set of guidelines where I can prove that the data is authentic. In this case, we are gonna prove first the authenticity source of the platform, of the passport. So the certification method that has been used is the blockchain satellite. So first I need to validate that the passport from Avicenna is currently stored in the blockchain satellite. So it has the same hash of the IPFS data, which contains the original data. Once that is hashed, you get the IPFS hash, And once you do a rehash of that hash, is the one that is in the blockstream data. So which means is the data remains double times safe in terms of immutable. This is easily done. You can go to the satellite option and you can paste the UID, the auth token, and the IPFS hash. Let's do this quickly for the demonstration. So this was the UUID, or that was, no, that's what the IPFS has, sorry. So now this is the transmission ID. I'm gonna paste this here, and I'm gonna pay now the authorization token. So I'm gonna validate this, and this means that this has been successfully validated, which means that the data comes from an authentic source and it's immutable. Now I'm gonna validate the signature authenticity. Basically, you can go to this website. There are so many websites similar to this, where you can verify in the Bitcoin network that a certain message has been signed. This is simple, and you can also do this with the Bitcoin command line interface. So I'm not gonna test this, as it's a very simple thing, but it just basically here saying that this is the message that we just sign, this is the signature, and well, here we can see it. This is the message, this is the signature hash, and this is the key, the public key, the wallet we used. This is the data, okay? And we're gonna validate that the authenticity of the medical record, which is here, is the same exact content, the content that is after the first page, because in this passport, the first page is the certification of the authenticity, and the second page is the actual data of the patient. So we can validate that this hash right here goes to a gateway storing IPFS with the same hash and the same content. And if it's the same content as this, it means that we have an identical match and it's the same content. Otherwise, we wouldn't have the same hash. So you can click in this hash. It will probably take a while if it has been refreshed and uploaded using the Infura API. But if it's using a local host, a local IPFS node, that will be instantly right away as you are accessing the same data. So if it loads, I will take a look and I will show you if this video has not finished yet. So the last check is the identity check. So basically I can go to the staff page and I can check if the entity that has provided a passport is a registered user. As we described before, only admins users can add doctor users. So every single user is registered in the platform, and because the way we have to authenticate users by doing a digital signature in the Bitcoin network, every single user is linked to a public key. If they have the same public key, it means that it's the same user. So we can go here to staff and we can check that a doctor called Carlos with this public key is the same user as the one who issued this here. So we have this key, and you can also check the same message. So me, Carlos, I agree with these terms, and this is the data. This is how it works. How can you validate? And this is how you can grant an identity, a healthcare system where it's safe to add data, is immutable, and is unfairly cheap for third world countries where it's complicated and they have their systems based on a paper health record. I'm gonna also showcase an insight of the Lebanese Association of the Order of Malta, where they have several challenges providing these features because patients have high complex medical needs, but they have limited resources and limited links to specialist cares. However, the reliance are on paper records, which means that they are very difficult to monitor clinical activity and those expenses to produce reports. This will radically change the future of, in this case, this volunteer camp called the Lebanese Association of the Order of Malta. Let's switch the role, and now let's go quickly to a staff which has the same role as a doctor, but they can also have edit a non-custodial donation page. This is inspired on Tipping Me, the Twitter tip page. So basically, in your profile, you can edit a donation page. First of all, before editing it, let me just show you what this means. You have here a donation page where you can receive donations by just printing this QR code, and you can receive donations from others in the first word or third word, doesn't matter. So you can have a text about what are you doing, what's your target as a clinic or healthcare facility or volunteer camp, and you can have a location of where you are located. Very simple, very straightforward. And the actual beauty of this page is that it's a public page, so you can have as many as clinics you can have on this system, and you can have a public entity, you can have public access for others to give you donations that go straight forward to you if you add this node. So let's say that you have an IPFS node, and then you have a Bitcoin and Lightning Network node, and let's say that you may not have internet access, but you have a transmitter and a receiver connected to the Blockstream satellite, and you receive payments in the Bitcoin network. If you by any chance you have internet in a sporadic time, and you make it to connect your Lightning node with the gRPC endpoint, the TL certificate, and the invoice macaron, this means that users will be able to access this page and donate through you. You can receive payments, and it'd be great the fact to know that are straightforward peer-to-peer, because we are only using the invoice macaron, so it's directly to your node, and this makes it non-custodial again. So this is how it works. You can also add some more details about your clinic, add pictures, like you have here. So now let's just finish. It's a pretty long video. I wanted to make it shorter, but it was so much data to cover. Sorry for that. Let's go to the GitHub really quick. So let's say that because this was a demonstration, so the actual website and the project was also intended and developed to show a showcase. So, but this is more in terms of the tech stack we've been using, because we're using open timestamps, Blockstream satellite for certification. We are also using OpenNode for a custodial service of Lightning, LN service for a non-custodial, and to create Lightning into the system. And it's very important for deploying this application to have an environment variable here. In this file, you would be able to see that you have the data from the host, the app, the database. You can add here your MySQL database. So Lightning details is an important thing. We didn't want to force a showcase, or we didn't want to force a successful or a for-profit business case where Lightning is integrated. I wanted to show specifically, Ludovic and me wanted to show specifically a showcase where Lightning can help healthcare solutions and can provide an efficient system where it's not only for profit. However, it can be done for profit, and it's very flexible. So I added this environment, and if you switch this to 0, it'll be as you saw it in the previous example. But if it's to 7, it means that 7 transactions 7 satoshis per every transaction that you are making are going directly to your node. So let's say that now it's 500, 300. So every number you put here is a commission that you take for every operation, every user that uses the certification, every user that takes anything. That goes directly to your non-custodial Lightning endpoint of your clinic or your network or healthcare facility that you have. In case that you don't want to have this, or because you don't even want to have a Lightning node and you don't want to mess about Lightning issues or Lightning infrastructure issues, you also can have the custodian Lightning endpoint using OpenNode. So this is set to true. In case you want to use the non-custodial, this needs to be set to false. But here you can have your OpenNode, withdraw API, and that's fine. Then you will be able to have this pretty straightforward. This is a password as a super administrator of the server, so you can self-destruct and don't have any hints or trace of the passwords once they are generated, as I showed you before. So it's very important if you could have a read to the wiki, as it covers more features, more details about the architecture, the way it's designed to have the UX layer, the IPFS layer in the satellite, and both interactions they have between, and how is the deployment of this project using, an IPFS node, and how to create an IPFS offline network, how it works, and more details about the problem. So this is everything. I'm looking forward to see how is the outcome of this hackathon. I'm very happy to have this opportunity of developing this project, and I have really enjoyed the development of this project. I've done this together with Ludovic, and it's been an awesome experience for me to be part of this. Thank you very much.